Hi, my name is Andreas Stockholm, and this is an introduction towards solving ambiguous SAR textures in convolutional neural networks for automatic SeaIce concentration charting. To see the paper, please refer to the QR code here or in the link in the description. For a more general introduction to automatic SeaIce charting, please see the video here. This is a radar image acquired by Sentinel-1 in Western Greenland, with SeaIce generally appearing as bright pixels, open water as dark pixels, and white pixels as a landmass. This is the equivalent SeaIce concentration chart produced by professional SeaIce analysts, with concentrations ranging from 0% as dark blue pixels to 100% as bright yellow pixels. This is then a typical output of a unit model trained on SAR data, where the model is clearly struggling in this area. We're investigating two hypotheses to improve model performance. The first is related to the receptive field, which is the number of pixels the model is able to see in the input when producing a pixel at the output. Here we then see a typical patch size of 512 pixels used for model training. The wedge square is then the receptive field of a standard unit of 188 pixels. If we first zoom into the patch and then further into receptive field, we can see that this area is very difficult to distinguish between SeaIce and open water. The second hypothesis is related to the SAR noise apparent in the Sentinel-1 measurements. This is particularly visible in the HV channel with long vertical lines at the subswath transitions. If we zoom in again, we can clearly see the sharp transitions between the subswaths. To mitigate this, we apply an alternative to the standard SAR noise correction, which we call the NERSC noise correction. Here we see that the long vertical lines are much less visible even if we zoom in. To increase the effective receptive field and further reduce SAR noise, we downsample our data from 40 meter pixel spacing to 80 meters. And already the model is able to see more of the input. Furthermore, we increase the receptive field of the model by adding additional levels. We define a level as a combined encoder block, skip connection, and a decoder block here. So this is a standard unit of 4 levels, where this is then a 5-level unit where we've added an additional level here. With 5 levels, the unit has a receptive field of 380 pixels. And we can now see that the model is clearly able to see much more details in the image. We can do this multiple times. With 6 levels, the receptive field is 764, with even more details apparent, and making it much easier to differentiate this area. Here are our results. We compare the model performance of both the SAR and NERSC noise corrections for each number of levels. We assess performance based on the R2 metric, which is a measure of similarity between model output and the reference ice chart. We see the model performance increases with higher number of levels. In addition, the NERSC noise correction is consistently scoring better. And we finally increase the number of levels all the way up to 8, where we see the best performance for our tests. We can also visually compare the model performances. In the top row, we have models trained on the SAR noise correction, and at the bottom in the NERSC noise correction. From left to right, we increase the number of levels. We see that the NERSC correction is consistently outperforming, and more levels are producing more homogeneous predictions, capable of correctly predicting the upper left corner here. Finally, we show the 8-level unit with a receptive field of 3000 pixels. Here, the resemblance to the reference ice chart is very strong. This is compared to the standard unit model trained on the SAR noise correction here. In conclusion, we see that adding more levels produce superior results measured on the R2 score with more similar homogeneity to the reference ice charts. We also see that the NERSC noise correction improves predictions and makes it easier to differentiate in areas of homogeneous SAR textures. There are still some remaining problems, such as fjords, which are incorrectly predicted up here. And intermediate SeaIce concentrations can also be improved, which we hope to achieve in the future. Thank you for watching this brief introduction.